All right, this is going to be a pretty quick lesson on factoring difference of squares. So this is Unit 11, Lesson 6, factoring difference of squares. Difference of squares is a special factoring pattern. So sometimes we can pick up on some patterns that can let us do some of the problems faster than others. So these are problems that I think you're going to like. They're just a very specific situation. So what I'm going to do to help you understand the pattern is show you the reverse of the pattern. I'm going to show you why we get the pattern in the first place. So we're going to actually distribute here to see what kind of problems we're really going to deal with. So bear with me here. We're kind of reverse engineering this pattern. So I'm going to distribute a to a gives me a squared. A to negative b gives me a negative ab. Positive b to a positive a is going to give me a positive ba, or I can actually call that ab because we can reorder multiplication. So I'm going to call it ab. And then positive b to negative b gives me a negative b squared. Okay? What you might notice here, hopefully, is that in the middle, we've got a negative ab and a positive ab. And that makes 0 because they're opposites. So this whole middle is going to go away, and what we're going to get at the end is just a squared minus b squared. And that's actually going to happen every single time you distribute this kind of situation, where you have the same number in front in both parentheses, the same number in back in both parentheses, but opposite signs in the middle. Addition over here and subtraction over here. So whenever you see the same thing in both sets of parentheses, with the only difference being addition in one and subtraction in the other, it's going to lead to this. A squared minus b squared. The first thing, the a squared, and then the second thing, the b squared, with a subtraction in the middle. Now we can use that backwards if we start looking at a squared minus b squared. We can go backwards and say, well, if I start with this, if I start down here, then I know it can factor into this up here. So we're going to take advantage of that pattern. Anytime we see a squared minus b squared, which I want to point out some things here, okay? We're seeing two terms. Both are what we would call perfect squares. And we have subtraction in the middle. If we ever see that, we get to use the special factoring pattern called difference of squares. Okay, so if we ever see subtraction in the middle, that's why it's called difference of squares. Subtraction means difference. Okay, difference of, and these are both squares, so it's difference of squares. If we ever see two terms with subtraction in the middle, we can go to this factoring pattern, where we take the square root of the first term plus the square root of the second term, and then we do the exact same thing but with minus in between. So we're just going to crank out 5 examples of this, and I think you'll start to catch the pattern. So I'm going to write this little in-between step on these problems that you don't really have to do, but I think it'll show you what's going on. So this problem, we have 2 terms, subtraction in the middle. X squared is always a perfect square. 4 is really 2 squared. 4 equals 2 squared. So what I'm going to do is I'm going to rewrite this problem as, and we don't have to do this step. This middle step is kind of unnecessary, but I'm doing it so you can see what's going on. X squared minus 2 squared. Which means we're in this situation up here. Difference of squares. One thing squared minus another thing squared. Okay, so this, according to the pattern, would turn into our answer, which will be x plus 2, x minus 2. And that's it. That's the whole problem. We don't have to do a t-chart or anything special here. We just get to go straight into parentheses. X plus the square root of the second number times x minus the square root of the second number. Again, this only works when you have 2 terms, subtraction in the middle, and both terms are perfect squares. So let's get to the second example, and we'll kind of skip that middle step now. Okay, so we have x squared, which is a perfect squared. It's x squared. Anything squared is a perfect square. And then we have 25, which is really 5 squared. So we have two terms. They're both perfect squares, and we have subtraction in the middle. So this is going to turn into x plus 5, x minus 5. The square root of each number, so the square root of x squared is x. The square root of 25 is 5. So x plus 5, x minus 5. If you think you're starting to get this, go ahead and just start doing the problems. I'm going to show you a couple more, but just start doing these problems if you think you understand it. So we have x squared, perfect squared, subtraction in the middle, and this is really the same thing as 10 squared, 100. And you can figure this out just by doing square root on your calculator. The square root of 100 is 10. So we really have x squared minus 10 squared, which means this can turn into x plus 10 times x minus 10. And one question I've been getting from kids, just since we started doing factoring, is does it matter if I write it with the x plus 10 first, or can I put the x minus 10 first? And it really doesn't matter. It's just like saying 3 times 2 or 2 times 3. They both equal 6. Doesn't matter which way you write it. Now, these last couple of examples are a little bit different, but not too hard. Okay? For this whole 4x squared to be a perfect square, both the number 4 and the variable aspect, x squared, both have to be perfect squares. Well, obviously x squared we've been saying is a perfect square, and 4 is a perfect square too. It's really 2 squared. So this is 2 squared x squared minus, and then 9 is really 3 squared. So we can square root both. The square root of 4x squared is, get rid of the squares on each of these, 2x. And the square root of 9 is 3. So we're going to have 2x plus 3 times 2x minus 3. So to get from where we started with these parentheses, or sorry, without the parentheses over here, to get from here to here, we have to square root everything we started with. So the square root of 4x squared is 2x. The square root of 9 is 3. So we have 2x plus 3 and 2x minus 3. That's just the pattern. So same thing here on this last problem for us. We have 9, which is really 3 squared. We have 25, which is really 5 squared. And obviously we have w squared, which is w squared. So we're going to square root everything. Square root of 9 is 3. Square root of w squared is w. Square root of 25 is 5. So we're going to have 3w plus 5 and 3w minus 5. So this factoring pattern that we used on all these 5 problems, it only works if we have perfect square, and subtraction in between. So 2 terms, both perfect squares, and subtraction in between. That's what we're going to be looking for on these problems. If you see a problem that looks like this, you got to realize, well, this isn't 2 terms. We have 1, 2, 3 terms. So it's not going to be a difference of squares problem. Okay? Same thing with a problem like this. It's not going to be a difference of squares problem. If we see a problem that looks like this, it's not going to be a difference of squares problem because it's addition in between, not subtraction. So you have to be careful. This factoring pattern we learned today only works if it's a difference of squares problem. And if so, we just use the pattern and it turns into a really quick factoring problem. And that's it for this lesson.